Again, we will take a look at finding the area of PQRS. Well, it would be more appropriate to have it going in either clockwise or anti-clockwise. So we could say, yes, PQRS. No problem with that. We'll also take a look at finding the area of the figure by considering that it could have been divided into two known triangles. There we go again. We have two known triangles. What do? For the right-angled triangle, we may say that the area is equal to half base times height. So that is your area, a half base times height. Base and height are perpendicular to each other. Let us use the perpendicular sides of the triangle in finding the area of the triangle. We know that we have a triangle, well, it has three sides. There's no difficulty with that. However, for the right-angled triangle, two sides are perpendicular to each other. When we need to find the area of a triangle, we have to use half base times height. In the event that that's what we are using, the base and the height must be perpendicular to each other. Therefore, we will use the two perpendicular sides. The two perpendicular sides are 6.9 centimeters and 4 centimeters. We are in no doubt that those are the two perpendicular sides. The other side is going to be the hypotenuse that we know is not perpendicular to any of the sides. So we may go straight ahead and use those two sides as our height and base, and we may use them in any order because they are going to be multiplied, and as we know, the order in which we multiply does not affect the result. The calculation is simple. A half of 4 is 2. Therefore, we still have 2 to multiply by 6.9. That will give us 13.8 square centimeters or centimeters squared. What about the other triangle? Yes, on this occasion, we are saying that we are also going to use area is equal to half base times height. How do we do that? As long as what we have as the base is perpendicular to the height, then we are okay. Half base times height may be used for this triangle also, with the height being perpendicular to the base. We may proceed. We are going to show that we have our height which is perpendicular to the base. We are choosing 8.5 centimeters as the base on this occasion. Therefore, what we consider to be the height must have two properties. It must be perpendicular to the base, and it must go from the base to the other vertex of the triangle. So we are saying half base times height, and we are saying that this is our base. The height must be perpendicular to the base, and it has to go from the base to the other vertex of the triangle. As long as those two properties are met, then we have our height that we can use to say the area of the triangle is half base times height. The base, no doubt, is our 8.5 centimeters, and the height is 4 centimeters. And of course, we know that from here, by the original statement of the problem, and also what we have here, which is a right angle, showing that this side is perpendicular to this one, and we know that these two sides are parallel, which will also cause this one to be perpendicular to this. These two sides are parallel. This side is perpendicular to this one. It is also perpendicular to this one, since these two are parallel. we will go straight ahead and make our substitution, where the base is 8.5 centimeters and the height is 4 centimeters. Now we are going to take half of something. It is easy to just take half of 4, which is 2. So half of 4 is 2, and we will then multiply that 2 by 8.5, and our result is 17. Finally, the area of the figure is the sum of the areas of the two triangles, and we have found the areas of both triangles. We just need to add them together. We are copying the value of the area from the area of the first triangle. No doubt we'll also copy the area of the second triangle from right there, so that those values are exact. The sum turns out to be 30.8 centimeters squared, or square centimeters. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.